Good day everyone. My name is Joshua Daniel C. Murillo. Today, we are going to talk about chemical reaction and its types. What is chemical reaction? A chemical reaction is in which the bonds are broken within reactant molecules and new bonds are formed within product molecules in order to form a new substance. Chemical reactions are all around us, from the metabolism of food in our body to how the light we get from the sun is the results of chemical reactions. Before beginning with chemical reactions, it is important to know about physical and chemical changes. A burning candle is the best example of physical and chemical change. Take a candle and light it. As time passes, we can observe that the candle changes to wax. If you cover the candle with a jar, it will extinguish. In the demonstration, burning of the candle is a chemical change, while conversion of the candle to wax is a physical change. In a physical change, there is basically a change of state of the substance, but in the case of a chemical change, mostly a new substance is formed in which either energy is given off or absorbed. Thus, we can conclude that chemical changes are accompanied by certain physical changes. In other words, chemical reactions occur when chemical bonds between atoms are formed or broken. The substances that go into a chemical reaction are called the reactants, and the substance produced at the end of the reaction are known as the products. Chemical reactions happen at a characteristic reaction rate, at a given temperature, and chemical concentration. Typically, reaction rates increase with increasing temperature because there is more thermal energy available to reach the activation energy necessary for breaking bonds between atoms. Reactions may proceed in the forward or reverse direction until they go to completion or reach equilibrium. Reactions that proceed in the forward direction to approach equilibrium are often described as spontaneous and reduce the free energy if they occur at constant temperature and pressure. Non-spontaneous reactions require input of energy to go forward. Examples include charging a battery driven by an external electrical power source, or photosynthesis driven by absorption of electromagnetic radiation, usually in the form of sunlight. Furthermore, different chemical reactions are used during chemical synthesis in order to obtain a desired product. In biochemistry, a consecutive series of chemical reactions where the product of one reaction is the reactant of the next reaction form metabolic pathways. These reactions are often catalyzed by protein enzymes. Enzymes increase the rates of biochemical reactions so that metabolic synthesis and decompositions impossible under ordinary conditions can occur at the temperature and concentrations present within a cell. The general concept of a chemical reaction has been extended to reaction between entities smaller than atoms, including nuclear reactions, radioactive decays, and reactions between elementary particles as described by quantum field theory. Here are the basic concepts of chemical reactions. A chemical reaction is a process that occurs when two or more molecules interact to form a new product or products. Chemical reactions plays an integral role in different industries, customs, and even in our daily life. They are continuously happening in our general surroundings. For example, rusting of iron, pottery, fermentation of wine, and so on. In a chemical reaction, a chemical change must occur which is generally observed with physical change, like precipitation, heat production, color change, and etc. A reaction can take place between two atoms or ions or molecules, and they form a new bond and no atom is destroyed or created but a new product is formed from reactants. The rate of reaction depends on and is affected by factors like pressure, temperature, the concentration of reactants. We will be discussing the chemical equations. Chemical equations. Due to the vast amounts of chemical reactions happening around us, a nomenclature was developed to simplify how we express a chemical reaction in the form of a chemical equation. A chemical reaction is nothing but a mathematical statement which symbolizes the product formation from reactants while stating certain conditions for which how the reaction has been conducted. The reactants are on the left-hand side, whereas products form on the right-hand side, connected by a one-headed or two-headed arrows. For example, a reaction A plus B, and that's going to produce C plus D. Here, A and B are the reactants which react to form the products C and D. In an actual chemical equation, reactants are denoted by their chemical formula. In order to assure the law of conservation of mass, a chemical equation must be balanced. That is, the number of atoms on both sides must be equal. This is the balancing of the equation. Let us consider an actual chemical reaction between methane and oxygen. Here, we can see how the number of each atom on the left side is balanced on the right side, as stated by the law of conservation of mass. Since we have already discussed the basic points regarding chemical reaction, we will now proceed to its types. Types of chemical reactions. The basis for different types of reactions is the product form, the changes that occur, the reactants involved, and so on. First, we have combustion reaction. A combustion reaction is a reaction with a combustible material with an oxidizer to give an oxidized product. An oxidizer is a chemical which a fuel requires to burn, generally oxygen. Consider the example of combustion of magnesium metal. Here, two magnesium atoms react with the molecule of oxygen, producing two molecules of the compound magnesium oxide, releasing some heat in the process. To sum up, a combustion reaction is a type of chemical reaction in which a compound and an oxidant are reacted to produce heat and a new product. In addition to heat, is also common, although not necessary, for a combustion reaction to release light and produce a flame. For a combustion reaction to begin, the activation energy for the reaction must be overcome. Often, combustion reaction begin with a burning match or another flame, which provides the heat needed to initiate the reaction. Once combustion starts, enough heat might be produced to sustain the reaction until it runs out of either fuel or oxygen. Second type is decomposition reaction. A decomposition reaction is a reaction in which a single component breaks down into multiple products. Certain changes in energy in the environment have to be made, like heat, light, or electricity breaking bonds of the compound. Consider the example of the decomposition of calcium carbonate, giving out calcium oxide, quicklime, which is a major component of cement. Here, the compound calcium carbonate, when heated, breaks down into calcium oxide and carbon dioxide. To sum up, chemical decomposition or chemical breakdown is the process or effect of simplifying a single chemical entity, normal molecule, reaction intermediate, etc. into two or more fragments. Chemical decomposition is usually regarded and defined as the exact opposite of chemical synthesis. In short, the chemical reaction in which two or more products are formed from a single reactant is called a decomposition reaction. The third one is neutralization reaction. A neutralization reaction is basically the reaction between an acid and a base, giving salt and water as the products. The water molecule formed is by the combination of hydroxide ions and hydrogen ions. The overall pH of the products when a strong acid and a strong base undergo a neutralization reaction will be 7. Consider the example of the neutralization reaction between hydrochloric acid and sodium hydroxide, giving out sodium chloride, common salt, and water. Here, an acid and a base, hydrochloric acid and sodium hydroxide, react in a neutralization reaction to produce sodium chloride, common salt, and water as the products. To sum up, neutralization reaction, a chemical reaction in which acid and a base react quantitatively with each other. In a reaction in water, neutralization results in there being no excess of hydrogen or hydroxide ions present in the solution. The pH of the neutralized solution depends on the acid strength of the reactants. Next, redox reaction. A reduction-oxidation reaction is a reaction in which there is a transfer of electrons between chemical species. Let us consider the example of an electrochemical cell-like redox reaction between zinc and hydrogen. Here, a zinc atom reacts with two ions of positively charged hydrogen, to which electrons get transferred from zinc atom, and hydrogen becomes a stable molecule and zinc ion is the product. To sum up, redox is a type of chemical reaction in which the oxidation states of substrate change. Oxidation is the loss of electrons or an increase in the oxidation state of chemical or atoms within it. Reduction is the gain of electrons or a decrease in the oxidation state of a chemical or atoms within it. Additionally, redox reactions are comprised of two parts, a reduction half and an oxidized half, that always occur together. The reduced half gains electrons and the oxidation number decreases, while the oxidized half loses electrons and the oxidation number increases. The fifth one is precipitation or double displacement reaction. It is a type of displacement reaction in which two compounds react and consequently, their anions and cations switch places, forming two new products. Consider the example of the reaction between silver nitrate and sodium chloride. The products will be silver chloride and sodium nitrate after the double displacement reaction. Here, silver nitrate and sodium chloride undergo a double displacement reaction, wherein silver replaces sodium in the sodium chloride and sodium joins with nitrate, becoming sodium nitrate along with the silver chloride as the product. To sum up, a salt metathesis reaction, sometimes called a double displacement reaction, is a chemical process involving the exchange of bonds between two reacting chemical species, which results in the creation of products with similar or identical bonding affiliations. It is a type of reaction in which two reactants exchange ions to form two new compounds. Double displacement reactions typically result in the formation of a product that is precipitate. The last type that we have is synthesis reaction. A synthesis reaction is one of the most basic types of reaction wherein multiple simple compounds combine under certain physical conditions, giving out a complex product. The product will always be a compound. Let us consider the synthesis reaction of sodium chloride with reactant solid sodium and chloride gas. Here, we have two atoms of solid sodium reacting with chlorine gas, giving out sodium chloride, this common salt, as the product. To sum up, a synthesis reaction is a type of chemical reaction in which two or more simple substances combine to form a more complex product. The reactants may be elements or compounds, while the product is always a compound. Synthesis reactions release energy in the form of heat and light, so they are exothermic. An example of synthesis reaction is the formation of water from hydrogen and oxygen. Synthesis is, in essence, the reversal of the composition reaction. Moreover, the hallmark of synthesis reaction is that a more complex product is formed from the reactants. One easy to recognize type of synthesis reaction occurs when two or more elements combine to form a compound. The other type of synthesis reaction happens when an element and a compound combine to form a new compound. Basically, to identify this reaction, look for a product that contains all the reactant atoms. Be sure to count the number of atoms in both the reactants and the products. Sometimes, when a chemical equation is written, extra information is given that might make it hard to recognize what is going on in a reaction. Counting numbers and types of atoms makes it easier to identify reaction types. Before we end this discussion, I will give 3 important points to remember about chemical reaction. The first one is, in a chemical change, a new compound is formed, but in a physical change, the substance changes its state of existence. Next, atoms or ions or molecules which react to form a new substance are called reactants. The new atoms or molecules formed are products. Lastly, a chemical reaction follows the law of conservation of mass. That is, no atom is destroyed or created, but only a new product is formed from reactants. These are the links of the references that I've used to create a profound video presentation. And if you want to have additional information, you can visit the listed links. Again, my name is Joshua Daniel C. Murillo, and I do hope that you've learned something in my discussion about chemical reaction and its types. Thank you for watching and have a great day.